So for your practice quiz for checkpoint number 15, here's an example of an equation in vertex form. And you're going to see a stopwatch pop up, and I'm going to give you 20 seconds to write down the end behavior. Begin. Okay, and stop, and let's go over the end behavior. Look at the A. Since the A is positive, we know that the parabola will open upwards. So the end behavior, as you go to the left, the y value or f of x value is going up, and as you go to the right, the f of x value is going up. Using the exact same equation, please identify the vertex. You have an additional 15 seconds. Begin. Okay, and stop. So this is in vertex form, so one of the advantages is we can easily see what the vertex is. The vertex is +3 and +5. Not -3, 5, but +3 and +5. Next equation. Please write down the next equation. Okay, you are going to have 1 minute to identify the X-intercepts. Begin. And stop. You can always rely on the quadratic formula to identify the roots, the solutions, the zeros, the X-intercepts. Remember, those are interchangeable words. But to save time, I would suggest first checking, can you factor? So 1 times 5 is 5. What multiplies to give you 5 and adds to give you 6? 1 and 5. And so x is equal to -1 and x is equal to -5. Remember, you're writing this as an ordered pair, so -1, 0 and -5, 0. Okay, so anyways, here's your next problem. Please write it down. Okay, there's your problem. You have 30 seconds to identify the X-intercepts. Ready? Begin. stop. So how can we do this? Well, I'm going to do a rough graph. So I'm going to go to the left 5. This will be my axis of symmetry. And then I'm going to go up 1. And this is the vertex. But for this problem, I asked you to identify the x-intercepts. Remember, we're working with quadratic functions. And with quadratic functions, we have the patterns of squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. And often we won't even get to 3 based on how far it is. So this means from the vertex, I'm going to go 1 to the left and 1 to the right because it's symmetrical shape. And this number will tell you, do you go up or down? If it's positive, you move up. If it's negative, you move down. And this tells you how many units to move. But if there is anything in front, it needs to be multiplied first times that y quantity. So now actually 1 times a negative is -1, -4, and -9. So starting from the vertex, I'm going to go right 1 to each side and down 1. And right 2 and down 4. And I don't need to go any further because the question specifically said, what are the x-intercepts? It didn't ask you to graph in any detail. So the x-intercepts would occur at 1, 2, 3, 4, at -4, and -6. To write those correctly, -4, 0, and -6, 0. Moving on to the next question. Problem is f of x is equal to 3 times x minus 4 and x plus 2. X minus 4 and x plus 2. You have 15 seconds to identify the y-intercept. And stop. When you're in the form, this is factored form, you can identify the y-intercept by multiplying these last numbers times the outside number. Now this is when it's not, when you haven't done the bottoms up. For instance, if you would have this part, what I'm saying to you is, so this is a different problem, is don't do the bottoms up. So don't push these bottom numbers up if you have fractions after you've reduced. Don't push those up. Leave it in this form. When it is in this form, we can easily identify the x-intercepts, and we can easily identify the y-intercepts by multiplying. Okay? So for this problem, 2 times -4 is -8, and -8 times 3 is -24. So 0, -24. Going back to that same problem we just did. When I ask you to, please find the end behavior. Go ahead, you have 15 seconds. End behavior for the same problem we just worked with. And stop. Since A is positive, I know that both on the left and right, the parabola is going to open upwards. So, as x goes to the left, y goes up, and as x goes to the right, y also goes up. Next problem. G of x is equal to 3 times x minus 1 squared plus 6. You have 15 seconds to identify the equation of the axis of symmetry, sometimes written as a line of symmetry. Those are interchangeable terms, line of symmetry or axis of symmetry. 15 seconds, begin. And stop. So I'm going to do a real rough graph here. This says go to the right 1 and go up 6. Right 1 and up 6. There's your vertex. Because it's positive, I know it's opening upwards. This problem asked to identify the equation of the line of symmetry. It cuts through the x-axis at a value of 1. Problem is done. For this problem, actually, let's do the next problem. Let's make it a little bit harder. F of x equals 2 times the quantity x minus 3 squared plus 1. Please make a rough graph, a very rough graph, and then identify the interval where the function is increasing. You have 45 seconds. Identify the interval where the function is increasing. Okay, and stop. Give you a little extra time there. Okay, so real quick graph. I'm going to go to the right 3. Axis of symmetry, also known as the line of symmetry. Go up 1. And then this function is opening upward because A is positive. So I know that's a very rough graph. We want to identify the interval of increasing. So as it goes up, it's also getting pulled to the right, and as it goes up on the right, it's also getting pulled to the right. That's why it's moving up in a diagonal direction. So when you describe intervals of increase or decrease, it's always in terms of the x value. So increase, from left to right, you're going down, so you're decreasing until you get to the turning point, and then it turns into increasing. Increasing only occurs after x is equal to 3. So it increases from 3 and it continues to increase as you move to the right. This is the interval of increase. As a reminder, intervals of increase and decrease will always occur with parentheses on both ends. Next problem. Seconds. Please identify the domain of the function. stop. Domains for all quadratic functions will be negative infinity to positive infinity. There's no restrictions how far it goes to the left or to the right. All right, your next problem. G of x is equal to the quantity x minus 5 squared plus 2. What is the equation for the axis of symmetry? 20 seconds begin. And stop. To visualize this, I'm going to make a quick drawing. I go to the right 5 and up 2. This function goes up because a is positive. The axis of symmetry, which cuts the parabola in half, making it symmetrical or equal on both sides, occurs 1, 2, 3, 4, 5 at x equals positive 5. All right, here's your next one. Your question will be to identify the vertex of the function. Identify the vertex. Identify the vertex of the function. You have 1 minute. And stop. Okay, so to identify the vertex, we're going to use this equation, which is also used for the axis of symmetry, or the line of symmetry. I'm going to substitute negative 6 in for B and positive 1 in for A. 2 negatives make a positive. 6 over 2 is 3. That's the y-coordinate of the vertex. Come back up to the original equation, and wherever you see an x, you're going to substitute in 3 for this problem. Three squared is 9. 9 times 1 is 9. 3 times 6 is 18 plus 10. 9 subtract 18 is negative 9. Negative 9 and 10 is 1. The coordinates would be 3, 1. Okay, using the exact same equation, y equals x squared minus 6x plus 10, you're going to have 10 seconds to identify the y-intercept. In standard form, the y-intercept is easily identified as the constant, the last number. So the y-intercept is 0, 10. All right. Identify the x-intercepts in factored form. Identify the x-intercepts when it's in factored form. 15 seconds. And begin. Okay, and stop. Remember, when it's in factored form, as long as you have not done bottoms up, we can do the opposite of this. One x-intercept would be -3/2, so the other would be +7/2. Writing it as a coordinate, these would be your two answers.